Conversation going. So, good morning, everyone. Welcome to this month's webinar hosted by the Florida Photonics Cluster. If you're not familiar with the cluster, it is a 30-year-old industry organization that was birthed out of the extraordinary anchor of defense and NASA and UCF in Central Florida and has grown into an organization with companies and academia, not only from all over Florida, but around the nation and even some international companies. And as many of you know, optics and photonics and lasers really are foundational to almost every other area of technology and industry, and certainly are having a very profound impact on the semiconductor industry. And that is the topic of our webinar today, obviously. It is my pleasure to welcome Dr. Volker Sorger, who is with the University of Florida and the Florida Semiconductor Institute. We shared some of his bio in the registration, and he has a very long, impressive bio. So I encourage you to go back and reread that. But you're going to hear this morning a lot of insight about his expertise, and he truly has a very international perspective and understanding of what's happening in the integration of photonics into the semiconductor industry, which is his area of expertise. So, Volker, we're so excited that you could join us this morning and looking forward to a great conversation over the next 60 minutes. For our guest, I will say that if you have questions, please feel free to put them in the chat. We'll try to get to as many of them as we can during the course of our conversation. This is being recorded, and we will share the link with all of you that registered and also be posting it on our YouTube channel. Okay, well, Volker, good morning. Good, thank you for being here.
Absolutely, been a true pleasure. Good morning, Carol.
Yeah. If you would, please just share a little bit about the Florida Semiconductor Institute and your role there so we can kind of put all this in perspective for our guest.
Yeah, absolutely. The Florida Semiconductor Institute is really a statewide institute. Yes, we're operating it mainly out of the University of Florida, but we have offices in New York cities as well, and there are other discussions as well. Jacksonville, for example. And the Florida Semiconductor Institute is really the entity that was sort of instigated by the state legislators to convene the industry at large, the semiconductor industry at large in Florida. This includes industry, this includes academia, and this includes
Mhm.
workforce association, and really trying to leverage all the good things that we do have and
Mhm.
double down on opportunities that we can chase after together.
Yeah.
My particular
Uh,
role is currently it's a mouthful, it's a deputy director for strategic initiative.
Yeah.
So I have opportunities to coordinate and um, think about strategic activities and initiatives that could really move the state forward and at a somewhat larger scale. And
Mhm.
I can give examples of particular discussions that are there, but I think we probably get there as like in our discussion as well.
Yeah. Well, thank you. And Volker mentioned Neo City. We'll talk a little bit more later in the conversation about Neo City, the Florida Semiconductor Engine, some of the other initiatives that may it may get a little confusing sometimes because there are a number of different entities involved, but they're all very interconnected. So we'll be sharing a little bit more about that. But before we get into the conversation, I'm certainly far from an expert in semiconductors or even certainly don't consider myself an expert in optics and photonics. So if you would, just the phrase silicon photonics, which many of us are hearing a lot about these days, and this whole integration of photonics into silicon. Generally, what is that, and why is it such having such a profound impact right now and such a focus of so much research and development?
Yeah. the let's say so silicon photonics is and I should really say it's really just a particular subset of the overall photonics field. Let's break it down, top down.
Yeah.
So I'm wearing my
Mhm.
professor hat now.
Good.
So optics versus photonics, right? So optics, let's say loosely speaking, we often refer to it as, let's say, free space optics. There's some sort of optic light beam. Think about a laser beam, laser pointer of sorts. And then we do things with that light beam. We have prisms, we have lenses, and so on. Yeah, microscopic in size, and so on. And there are many industries which use them daily. Think about projectors, yeah, beam projectors,
Hmm.
flight simulators, planetariums, and many other technologies. And certainly fiber optics is kind of almost in this way as well, which of course
Hmm.
has revolutionized the industry. See Tom Jahauskin's here. Hi, Tom, on the in the audience as well, and others who really have basically driven and really riding this technology as well. Now, what's photonics? Photonics is we put optics on a chip. It is sort of the emergence of semiconductors and optics. That's basically photonics. This includes
Hmm.
then tiny laser devices that are micrometers in size. This includes electro-optic modulators, photodetectors, waveguides, passives, actives, and so on. And then, of course, the packaging thereof. Now you
Hmm.
ask, Carol, that's a good question. So why? What's the big deal about this these days? Like, where are the upsides and are there any downsides? Well, let's talk about the upsides. I mean, very fundamentally speaking, not to get too physicsy here, but an optical signal, let's say in a telecom wavelength, can carry an absolutely massive amount of information. If you apply some is a Shannon limit, for example, at 193 terahertz of of a regular baud rate of a signal at, let's say, 1550 nanometer telecom wavelength as an example, you can basically you can sample it by you can divide it by a factor of two, so which is roughly it's 100 terahertz or 100 terabits per second. So a
Hmm.
single fiber or single optical waveguide can be a tiny nanometer, like tens of or hundreds of nanometers small waveguide, can carry a massive amount of information, much more than an equivalent like electronic signal can do. Yeah?
Hmm.
Um, that's a big upside. The other upside is we can, so of course, photonics has been historically always used for data communication. This has
Hmm.
to do with, of course, photons are bosons, not fermions, very physics terms. But at the first order, basically, photons don't see each other, and they are fantastic to transmit information. And that's what we have been using in data centers. And data centers and AI, I mean, the revolution of AI is so massive. The entire
Hmm.
field, I would say, is at first order at this state in 2026. I don't know, put a number out here, an 80 to 90% dominated by one market. That's basic AI, and that's data centers.
Hmm.
And that is good news for photonics. In fact, announcements made by CEO Jensen Huang of
Yeah.
NVIDIA and others, just as of late as last year, 2025, have absolutely one more time ignited the already very,
Hmm.
very strong optics field and
Hmm.
photonics field
Hmm.
to yet another level that we have not seen probably since the emergence of the internet in the mid 90s. So there's a very exciting time for photonics. There are still challenges ahead. But to wrap up, like my question, Carol, you asked, okay, so why silicon photonics explicitly? And again, I said that's just one part of it. We need lasers. Silicon doesn't produce laser like light. It's just an indirect band gap. So we want to. There are other materials as well for the lasers. Indium phosphide, gallium arsenide comes to mind, etc.
Hmm.
And there are companies who really double down on that very strongly. We saw also announcements from NVIDIA investing into
Hmm.
various companies, lots of cash actually, like literally cash. We also need to design new EDA tools, like design tools, which are certainly lacking in photonics. Not that we don't have any, right? All the big companies, Synopsys, Cadence, Silvaco, you pick your Siemens and so on, have great tools,
Hmm.
absolutely, right?
Hmm.
But we still, the way I say it is like this: if you were to bet let's say something significant, let's say your house, yeah, if
Hmm.
you were to bet your house and on an electronic process, like whatever 22 nanometer process, and if you would win, you get it right, you would get something very great from it, you would probably do it because in electronics everything's is pretty mature, understood, and stable,
Right.
yeah, and tested. Photonics, not so much, right? you would probably not bet your house. You maybe would bet, I don't know, maybe $10,000 or something, whatever, something smaller, right? But certainly not your house. So, and this is something to do that we need to address in the industry as well. And there are answers to that. But again, just bringing this EDA aspect about this as well. EDA can help. Digital twins as a keyword can help a lot.
Hmm.
We can discuss that too. But yeah, silicon photonics has sort of emerged as, to wrap up then the question, as a key topic, that a key area where we really are using the best of silicon processing that is in existence, the tools, the equipment, the applied materials machines, yeah, the various processes, the lamp etchers, you name it, out there are that process electronic devices can absolutely also etch a waveguide, which, by the way, has a much larger dimension than an, let's say, critical dimension of a modern transistor, for example. So there are other challenges in photonics. We can discuss them as well if you like, but on processing. But at first order, there's a nice synergy between this. So that's why silicon photonics is a very nice platform. Now, the last comment on that is what is exciting that some foundries, there's really just one or two come to mind, TSMC and Global Foundries, that are, and to a lesser degree, Tower Semi, that are able to provide both basically a monolithic integration of CMOS, meaning transistors, which you need for
Hmm.
all sorts of drivers and conversions, ADCs, DACs, ADCs, digital analog converters, basically, and amplifiers, and all these support infrastructure
Yeah.
that you need for the optoelectronics to work and function properly on the same monolithic chip. You have your transistors and your
Hmm.
circuits sitting literally right next to
Next to each
your
other.
photonic devices.
Hmm.
And that's one way of doing it. There is another way to do it in three dimensions. But yeah, but silicon photonics is a very leverage the maturity that silicon processing offers, and
Hmm.
adds now photonics on top of this. And the upsides could be bandwidth density, and bandwidth energy efficiency. So,
Hmm.
and
So lower
mhm,
power consumption, potentially, eventually lower, more capacity at lower cost, perhaps, as we get to a more, state of the art, it sounds like. So, when I start, it's really exciting to me from a Florida Photonics Cluster perspective when I start seeing optics and photonics mentioned in the more popular, more consumer-oriented business literature, right? Because typically when you mention optics and photonics or lasers to someone who's outside the industry, they have no idea what it means or why it's so important in their life and affects so much of what they're doing. But being able to explain the impact for artificial intelligence, for data processing, for biophotonics, medical
mhm.
applications, certainly, so so many areas, certainly defense, space. It begins to start to dawn on folks that I talk to that, wow, this is an area of innovation that I didn't know about or wasn't aware of, and I really want to know more. But you touched on them a little bit, but there are some significant hurdles, I guess, would think, to commercialization, to the whole manufacturing of these kinds of devices. I read a lot about the packaging, co-packaging and challenges there, but even just the materials themselves. Talk a little bit about that, because for some of our guests that may be doing research and development, looking for those signals of where they might want to pursue their own internal research and development, or pursue research opportunities with the universities or with other companies to really help move this forward, present some good business opportunities.
Oh yeah, and there are quite a few. So whilst on the one side, yes, we are leveraging semiconductor manufacturing tools and equipment. That's great, and that's exactly what we should always do. But there are significant also challenges, and that's maybe from an R&D ecosystem, which I would sort of say, if I went on my Florida hat, I would say we are probably pretty good at that, yeah, at
Hmm.
research and development. We indeed have not huge. mega fabs, yeah, like
Hmm.
maybe Arizona is pushing right now, and
Hmm.
Texas, and we can discuss that maybe later as well on the ecosystem
Hmm.
side. But yeah, but maybe just to be a little more on the technical side. So challenges about photonic manufacturing. Turns out photonics works extremely well in the lab, but lab to fab is the challenge. Yeah, the real challenge in manufacturing is to manufacture it at scale, which means cost,
Yeah.
yield, reliability, and this all trickles down into, of course, the bottom line, right? For like for industry. So if you have mentioned a few, let's say, mentioning a few items explicitly, number one, heterogeneous like material integration. Core challenge is
Mhm.
so unlike in CMOS electronics, we have multiple material platforms providing multiple functions. You mentioned silicon, good waveguide. Oh, it turns out silicon nitride is even a better waveguide. Lasers, you need indium phosphide or gallium arsenide, for example. Modulators. Yeah, silicon depletion, carrier depletion is decent. You can also think about merging one thin film lithium niobate, for example. It's, for instance, from pure bandwidth, you don't move carriers, you just apply electric fields. So you can go
Mhm.
hundreds of terahertz, hundreds of gigahertz, terahertz would be great, hundreds of gigahertz, versus with carriers in silicon, you're pretty much limited to maybe 50 to 70 gigahertz, and you can overclock them, let's say a little bit to 100 gigabits per second. But again, germanium makes great detectors. Yeah, other 3.5 material integration. So
Mhm.
on number one, again, heterogeneous material integration. That's one aspect. Second one is integrating laser. Usually, you separate the passives from the actives. Yeah, let's say passive chip, silicon photonics, for example, silicon nitride photonics. And then you just somehow bring the laser in, either through couplers, through edge couplers, through the laser that sits externally. You can also flip chip the laser on top, like on top of this. You grow things heterogeneously, and there are companies all over the place on all these, like in all these areas.
Okay. Yeah.
So heterogeneous versus monolithic integration, because once it go heterogeneous, cost goes up, time goes down, yield usually
Yeah.
goes down. But on the device side, yeah, you get the best of each world then, and you just package and stitch it together. But that is then the cost need to consider. Yeah, thirdly, packaging alignment overall. In many photonic systems, packaging costs exceed the fabrication cost. So
Mm.
that's and it can be depends on your process, of course, but numbers swing between 50 to 80% of
Wow.
the module is the packaging
Packaging.
aspect of it.
Yeah. Mm.
And that's, of course, something that our engine, we will talk about the engine later as well, has one of the key topics that where
Mhm.
innovations are needed, and where
Mhm.
companies ought to manufacture. And it is, of course, all the old items, yield needs to go up, but also time goes down. There are some interesting, just to mention one item, and I know a few players are moving into more and more into the Florida ecosystem. Actually,
Mhm.
German companies, in fact.
Mhm.
Like big shout out here to maybe like to CEO Thorsten Meyer from Vanguard
Mhm.
Automation, which is now like an Micronics company, and then Ficontech.
I can do. Yeah.
Right. So which is like at UCF and like
Mhm.
like like an ecosystem as well. The both like
Right.
both companies target to address the advanced packaging
Yep.
and the test aspect as well. But certainly, how can we improve and get faster with packaging photonic components, the fiber to a
Mhm.
photonic integrated circuit, the laser to a
Mhm.
photonic integrated circuit, yeah, the laser to a fiber, and all combinations thereof. That's the third thing. Fourth thing, yield wafer uniformity. Do we have enough, for instance, in optics, we deal often with phases, with resonances, yeah, insertion loss,
Mhm.
coupling efficiencies. So all of
Mhm.
these are items that we need to have more, let's use the word fidelity of and control over those processes. Yeah. And
Mhm.
lastly, thermal management. In
Mhm.
many optoelectronic devices are temperature sensitive. So we want to make sure that we understand the process and the application and ultimately the system. It's a system design question to that
Mhm.
level. And in fact, to mention a number here, some of these, let's say ring resonators, they need to be stable within 1 or 2 degrees.
Oh,
And then the
goodness.
question is, can we control this passively, actively?
Mhm.
So there are some, companies also we have in Florida actually that are very have good expertise on this. Maybe shout out
Mhm.
here to like L3 Harris
Mhm.
and Rogue Valley Microelectronics, which set
Mhm.
up a 300 millimeter fab now here in Florida as well, which
Mhm.
is fantastic.
Mhm. I am like you seeing companies coming into Florida. We're getting new members of the Photonics Cluster that are in the packaging area, that standing up their U.S. subsidiary here in Central Florida or expanding here from other parts of the countries. So once again in this area, and I think more than we've seen in a while, the strength of the Florida ecosystem and the strength of the cluster in academia and industry and the application industries that are going to really drive the adoption of this innovation and this integration are here. So let's talk a little bit about that,
Hmm.
markets, because uh, we know those of us that live in Florida that we have extraordinary depth and capacity in research and development and academia and industry and all sorts of supporting organizations and defense and aerospace, space, maritime, environmental, manufacturing, healthcare increasingly. Where are you seeing which industries are really driving, from your perspective, the development here and are likely to be some of the earliest adopters of silicon photonics?
Yeah, so certainly what is has been publicly claimed is obviously AI,
Yeah.
for the reason we know, for optical interconnects, because modern workflow of AI
Hmm.
require massive amount of data movement,
Hmm.
and compute is making steady progress. Compute has its own limitation and challenges, but it's making progress as well.
Hmm.
The interconnectivity, however, if you plot also compute versus interconnectivity, and the interconnectivity lags behind. There's a gap opening, and the one thing that photonics is and optics is extremely good at is sending data. Again, this high capacity that we talked about at the
Hmm.
beginning.
Hmm.
So that is something that has been clearly recognized. The term many of course on the call I'm sure have heard this, that has been coming as a next big step is now co-packaged optics. What this
Yeah.
basically means is you take a photonic integrated circuit, you integrate this very, very closely to electronic chips on the same
Hmm.
package. Yeah? Not just
Hmm.
on the board itself, but you put it already even
In the
onto the
chip.
same dies.
Yeah.
Yeah, you got them
Mhm.
in talking
Wow.
about in substrate
Hmm.
co-integration. Um, what's going to happen? So that basically brings this high bandwidth. Think about you basically bring a highway like a highway, think about like let's say European cities, and if you can, like the city centers, there's always like there's cathedrals there, right? And it's very hard to get to. But imagine
Hmm.
you have this, 6 lane highway, and you immediately get with that 6 lane highway down to the let's say Germany, like Cologne Dome, right? Like this
Hmm.
big huge cathedral, and you're right next to like get to the six lane highway right next to it. So that would obviously
Hmm.
drive a lot of traffic. Now there could be
Hmm.
other downsides, but that's sort of like the idea, right? About
Hmm.
like photonics. So for AI, that's a given. There's no question for this anymore. And I would even lean myself further out the window and say it's not just for not just for interconnects and data sharing. It is even for compute as well. Let's say if you now bring an optical signal very, very close to a compute core, then it begs the question, well, why don't you actually do some computing already in your optical domain or like as well? In fact, my research
Hmm.
group here at UF, we're actually doing this, and there are some startups. Stay tuned for Florida as well
Hmm.
in this space as well. So let's put a big check mark on this, yeah? Like on AI data center acceleration, hyperscalers,
Yeah.
basically. Let's another topic where I or field where photonics can make very big strides on is space technologies.
Yeah.
And I'm literally not saying this because we're sitting in Florida, and I'm not saying this because Last Friday, we sent our second chips actually with the
Up on the
SpaceX
launch. Yeah, yeah.
CSR 34 mission to the International Space Station
Hmm.
with the NASA program. I'm not saying
Hmm.
it's because of this, but I'm saying it's because it makes logic sense. So,
Yeah.
for example, think about think about how the size of electronic devices, a transistor. It's tens of
Weight, heat, size, all of that. Yeah.
it's very, very tiny,
Hmm.
right?
Hmm.
So now think about a cosmic ray zooming through that chip
Hmm.
and
Yep.
destroying the ladder structure of that silicon.
Yeah.
If um, if there's one or two defects now in
Hmm.
that tiny few nanometer channel in a
Yeah.
silicon transistor, that transistor is basically gone.
Yep.
It's not
Hmm.
functional anymore.
Yeah.
So the downside, the formerly downside from photonic devices, which are more we talked about earlier, maybe hundreds of nanometer to micrometer in size,
Hmm.
is now positive when it comes to resiliency because
Yeah.
that cosmic ray, that single cosmic ray, destroying certain, say, silicon photonic lattices. It's if it's 400
It's
nanometer
like
wide, the waveguide, not such a big issue.
yeah,
Mhm.
you've got so much more capacity to overcome that and not have the same effect. So, um,
For example, yeah, again, so
yeah,
that's why I think space, and then there could be even more defense-related
depends.
applications,
Yeah.
less carrier density in photonics, for example,
Hmm.
which makes these devices much more resilient against certain counterattacks. So, and that's certainly something you mentioned as Carol too, right? I mean, we have 22 military bases in Florida. We
Hmm.
have 5 deep sea ports.
Yeah.
We have space
Hmm.
force here, right?
Hmm.
Various commands here.
Hmm.
We have, of course, Cape Canaveral. So
Yes.
if space, it is happening here. And I think the merger, I'm very, very excited to see not the merger, but the synergies between our very strong photonics, your cluster, right? Our cluster,
Hmm.
our ecosystem,
Hmm.
plus our, yeah, 70, 80 year legacy in space merging
Right.
now.
Yeah. Let's talk a little bit about how, industry and even academia can engage here because so we have the initiatives from the Semiconductor Institute based at University of Florida. We have the Florida Semiconductor Engine, which for those of you that are not familiar with that, we'll have Volker talk a little bit about it. That initiative, federally funded under the CHIPS Act, is anchored in Osceola County, just south of Orlando, and is located in a whole evolving city, basically, called Neo City. You may remember Volker mentioned Neo City early on in this conversation. That is literally a whole community that is becoming more and more populated with industry that's moving there. There have been some very large announcements of companies that have expanded and are standing up facilities there. There is a wafer fab facility that's doing work with DoD and industry. So give us a lay of the land of what the Semiconductor Institute is, what the engine is, Neo City, how it's all working together, and then let's talk about opportunities for companies to partner with the engine or the institute to help address some of these challenges.
Yeah, wonderful. Well, let me maybe say up front what a strategic positioning overall for like for off Florida is today, and then how that ties into these we use the word clusters now and individual pockets of excellence that we do have. So the strategic positioning of Florida is it's we're really evolving or adding to, not that we're giving the other one up, from a tourist-driven economy to a high-tech manufacturing and defense innovation hub. That's really what's happening, Carol, yeah, in Florida
Hmm.
right now.
Hmm.
So we see a strong convergence of again, semiconductor, aerospace, defense, data center economics, photonics, advanced packaging, marine to some degree as well,
Hmm.
and healthcare through our great we are a great state to retire in, as we know. Yeah?
Hmm.
So here's what Florida is not doing. Florida is not trying to replicate Arizona, Taiwan, or New York. These states have TSMC and other big companies have doubled down on these states as their manufacturing hub for
Hmm.
advanced chip manufacturing, meaning 5 nanometer node, maybe 3 nanometer node, and like and beyond. What Florida's opportunity is lies in the other aspects, and we coined the term specialty electronics, which
Yeah.
includes photonics, MEMS, and other devices and other systems. So this includes advanced packaging, this heterogeneity of integration, these multiple material platforms we talked about,
Hmm.
photonics, defense electronics, and a very strong aspect of workforce like innovation and development.
Hmm.
And I can really give a if that's appropriate here, shout out to our governor Ron DeSantis, because he saw that as a vision and has doubled and tripled down on it. So he has invested roughly $400 million specifically in workforce development. In fact, and then maybe some people may say, "Oh, but you sit in your ivory tower at the university, so now you get a lot more money from the state." Turns out we get actually from that funds zero, and all these funds went to our tech and community colleges. Yeah, you
Hmm.
mentioned Valencia College, for example, and others. And I think this is a very great vision because this really develops a vision of investing into not just now and the next 2 or 4 years, but it's a vision of developing a workforce and give and build capabilities in the state for the next 10 or 20 years, for the next
Hmm.
decades.
Hmm.
So that's just like a preamble of this. Now let's talk about our ecosystem. So we have certain strengths. So we have a very business friendly environment, right? We have no state income tax. We have a rapid population growth. That's fantastic. That's good. Good infrastructure, logistics is well established. We have these major aerospace defense presence. We have a large like veteran workforce that we can still leverage. They are
Hmm.
individuals who are not 80 or 90 yet. They could
Right.
still give back or still
Right.
maybe want to engage. Maybe not, but maybe they do, right?
Right.
They are usually at the top of their career peak,
Hmm.
and we have a
Hmm.
growing advanced manufacturing base. So
Right.
so what does it mean now for key ecosystems? Okay, so let's break it down. We have the Florida Semiconductor Institute. It is this entity that is basically convening the our overall semiconductor activities, including academia, including all the colleges, tech colleges. In fact, everything from K to 12. We have a lot of
Hmm.
activities on that as well. We can talk
Hmm.
about workforce later. Industry and governmental partners, again, mentioned these 22 military bases and so on. Yeah? So it's really in all of the above. Plus, let me add one that we, in the first 2 years, did not think about too much, but we are very, very keen and very focused on this. And this is basically our innovation ecosystem. Let's say
Hmm.
our venture like capital firms, um,
Our
um,
incubators, our accelerator programs,
exactly,
we have
100%.
such an amazing ecosystem that supports early stage companies.
And Plug and Play moved here, right? They're like the only
Yes.
silicon, like I only not
Semi
silicon, the
Well, their
only
only
semiconductor
semiconductor vertical, right, is in Neo City.
vertical
Yeah. Yeah.
is in New York City, exactly,
Yeah.
right? And that is one of many, right? We have like
Yeah.
DeepWorks, we have many other
Yeah.
venture arms in Florida, and then
Hmm.
there's a whole Miami ecosystem, right? With
Yes.
a lot of fintech and I think growing these connections with across these verticals is something we should do more of. And again, that's something as like specifically at the Florida Semiconductor Institute is really like a convening entity for the entire state of Florida,
Gotcha.
all the way
Mhm.
like in Pensacola, all the way down to Key West is something we're really trying to do. Yeah?
Mhm.
Now, what's the Florida Semiconductor Engine?
Engine. Yeah.
So right, Florida Semiconductor Institute, Florida Semiconductor Engine. It almost sounds okay. What's the difference here? So the engine is a specific. Um, it's a regional as opposed to statewide. It's a regional focus. It can certainly trickle down into the entire state and the entire nation and beyond. But the focus is to have a somewhat regional, geographic regional cluster that focuses in this case around a certain topic or topics,
Mm.
plural, not
Yep.
just semiconductor at large. That again, as we said before, we don't do front end, these 3 nanometer deep like lithography and so on. But for instance, is really focusing right now like in New York, or at least intended
Hmm.
to in other areas. But we focus on what do we do focus on? We focus on advanced packaging, so the back end aspects, stacking these chips in 3 dimensions, and photonics, quantum technologies, including cryogenics. And we have a great spin out from that, Snowcap, which also sets up more shop here in Florida, which is pretty fantastic. And then I would say digital twins and building
Yeah.
models.
Yeah.
Maybe quick keyword, what's the difference between a model and a digital twin? Well, everyone has a model, right? You model something in a simulating like environment, pick your favorite software tool. Digital twin is a model that we have calibrated. I always say, gold in, gold out, or you can flip it around. You can say garbage in, garbage out, depending which view you
I
have.
like gold
But
much better. Yeah.
that's what I thought exactly. I kind of flipped this, oh, platinum in, platinum out. Here we
There you
go.
go. Yeah.
Um, but whatever you put into the model is pretty much what you get out. So you need to
Yeah.
somehow make sure that the system is calibrated properly, and that's where the twin comes in. Which means we will partnerships with fabs where the manufacturing facilities share some of this maybe data with the modeling sides of the equation to
Hmm.
get a better model to. We talked earlier, what Carol about is get it first right? You would bet your
Right.
house or you would not bet your house in photonics.
Right.
If we would have that, that would be a huge, huge win in photonics. So if we would have a very, very detailed model, this of course is getting, however, very sensitive. You can imagine data, which fab likes to share data with external entities, right? So that needs to be very closely, carefully orchestrated. But it is possible where if there's a will, there's a way. So Florida Semiconductor Institute, big picture, convening all players. We host an annual conference. We call it the Florida Semiconductor Summit. It is always in February, like time frame. So anyone's invited next year to participate. You can companies, you can host you can have a booth there. You can like this is workforce development for your marketing, your executive meetings and so on. So really a fantastic place to work. Now, the Semiconductor Engine is explicitly in regional Orlando and Greater Orlando region cluster
Mm-hmm.
activities around these topics we just like mentioned: advanced packaging, photonics, quantum, cryo, and digital twins. And it's funded by the National Science Foundation. So therefore, it has a bit of research and development spin. It certainly is research and development. It's not geared
Hmm.
towards large volume manufacturing, although certainly technologies can ripen up to
Right.
that. That would be fantastic, right? And it has a very strong workforce development, of course, as well, attached to this.
Yeah.
Again, the engine is physically located in New York City.
In
New
your
York
city.
City, you could just Google it. It's in Kissimmee,
Yeah.
south of Orlando. It's near the Kissimmee Airport, which I as a pilot appreciate because it's just 10 minutes
Yep.
right from there, and they have great courtesy cars. So it's
Yeah.
that's something I love about our aviation ecosystem.
Yeah.
You can fly somewhere, take a little car, go to your meeting, come back. It's
Yeah.
uh, it's it's absolutely amazing.
Yeah.
No other
Well,
country really
I
has this.
yeah, I think and what I love about this whole area of innovation is how it just really shines a light on, laser beam on, the unique attributes and capabilities of so many of our universities as well. The UF with the world-class artificial intelligence capability with NVIDIA and materials science and electronics and all the work that UF's done over the years and the Semiconductor Institute being there, UF being a land grant university with a statewide mission, with a national mission. University of Central Florida in Orlando partnered with the Florida Semiconductor Engine with one of the world-class colleges of optics and photonics and extraordinary expertise in digital twinning because of all the long-standing work with the military and space and so many other industries. And extraordinary vision and support of local government. For those of you that aren't necessarily aware of it, Osceola County and other counties in the area have long been put millions of dollars into supporting economic development and supporting key initiatives. And I just really want to give a shout out to Osceola County government for their long-term vision that started, what, 15 years ago to really even, help support the standing up of the fab facility and support the pursuit of the engine, which has been certainly a very uh, extraordinary regional collaboration, but a statewide collaboration too. So it's not just industry and academia or dollars from the state. It is the local government here in Florida that's really helping support this as well. And then Neo City, that physical community where there's really wonderful research and development and office facilities, a lot of residential property being developed as companies are moving there and others are moving there. So it's just really an extraordinary time across Florida in a lot of ways, but I think particularly in this area. You mentioned workforce development, and we have our colleges and universities, certainly University of South Florida, every university. I would say, is it fair to say that almost every university in Florida is doing some work, relevant work in this area, but probably led by UF and UCF to some degree? Is that a fair statement?
At first order, to some degree, yes.
Hmm.
And certainly in advanced packaging
Hmm.
and process developing, also FIU,
Hmm. Yep,
like Raj and his
right.
team, and John,
Yeah.
also on the RF side.
Hmm.
Yeah, there are. I think what we can, and we could, of course, we can also discuss what we can still maybe do better as well, how we can even work more synergistically together as well. One thing, for example, is we do to help this from the Florida Semiconductor Institute. We developed a map of Florida where you can sort of
Yes.
toggle on various either industry aspects
Hmm.
or clean rooms for early R&D or
Hmm.
suppliers, gas, material
Hmm.
suppliers to the ecosystem, and so on and so forth. And I think it gives a bit of an overview. And then if you click on each of these buttons, it gives directly a link and contact into like information, or at least as a very minimum, like a website to dig deeper and to connect more. And since we're now talking about this photonic thrust, we started to do build or develop
Similar.
something similar
Yeah.
for photonics specifically,
Yeah.
correct? Because it's a
Yep.
different ecosystems, photonics, of course, and optics also connects to various different types of material processing,
Hmm.
thin film depositions, such
Hmm.
as maybe infrared coatings, for example, anti-reflection coatings for various optical camera systems, etc. I think it would be very good to have this. And so for everyone on the call, there is development on this as well to again align ecosystem.
Yeah.
Carol, we also incidentally we have two questions in the chat.
Yep.
Not sure whether you
Yep.
want to take them now or anytime
Yeah.
later.
Let's if we maybe finish the workforce conversation here. And thank you for mentioning the resources on the Institute website. I was going to ask you to mention those. And for all of you that are joining us this morning, we've thrown a lot of different organizations out there and resources. When we send out the link to the recording for this webinar, we will include the links to all these different entities and organizations that we've mentioned so that you'll have those. But I do want to go back to just workforce because in every industry I've ever worked with, the talent pipeline has been crucial. And certainly in this field, because um, it's just growing at such an exponential rate in terms of the applications and the innovation. So you we've talked a little bit about the colleges and universities, and certainly UF, UCF with the College of Optics and Photonics and all the work that they've done. Valencia College, we're very thankful for their 2-year optics technician program that they've stood up in partnership with AmeriCom. And AmeriCom is an organization that is actually funded by the Department of War to do not only coordinate some research and development initiatives, but especially on this workforce side, to partner with state colleges and community colleges to stand up these technician-oriented degree programs. Indian River Community College still has, they have some certificate programs as well, and there may be some others. The the K through 12 area is very critical in STEM education, science, technology, engineering, and math. Neo City, who that we've talked about, has a whole academy. It's literally across the street from the fab facility down there, basically, where they are working very closely with the semiconductor industry down in Neo City and creating that pipeline starting at very early age. And there are other organizations around the state. I know University of Central Florida, the College of Optics and Photonics has student photonics camps they do each summer. They have educator workshops. I want to give a shout out to Orange County government in the Orlando area who funds the Florida Photonics Cluster to do STEM education because they recognize how critical this industry has been and is and will be to the economy of Central Florida and the state as well. So there's just a lot going on, and I'm reading about organizations all the time. We're in conversations with different organizations like the Sparks Foundation about curricula that they have to look at bringing into the state, into some of the other school districts as well. But what have we missed anything, Volker, in terms of the workforce training?
No, that was quite extensive indeed. Yeah, I was just thinking, maybe not to repeat too many items, but
Mhm.
so here's one thing actually we did do. Gosh, this is like 3 years, 2 years ago now. Yeah, about well, like about 2.5 years ago, we
Mhm.
did we did it together like with Karen Hoffman, and uh the idea was to be like in the room
Mhm.
and with various industry leaders. And I'm saying this because I think we should probably repeat that. But it was a very good exercise. It was we tried to define particular skill sets, actually
Ah,
skills
mm,
that industry expects and demands
mm,
for their own, um, utilization,
right.
uh, for a variety of degree levels. Let's
Mhm.
say high school, 1 year
Right.
college, 2 year college, 4 year college, and maybe above master's
Yeah.
PhDs. Yeah, and that was very very insightful to
Mm.
see how much of which skill and is needed for depending which degree you achieve. Huh?
Yeah.
It's almost like a like a
A
like an
map, a
option
roadmap in a
to
way.
move, like a
Yeah.
roadmap.
Yeah. Yeah. Yeah.
And and of course, this is shifting and changing, right? But with time, and
Hmm.
this is now like 2.5 years later. I think we should probably go back and redo that. And I remember it was very, very informative. The yeah, like the cluster of information that we gathered from this, and we
Hmm.
still you know use this to guide again to basically build a bridge between the demand side, the industry
Yeah.
side, and then the supply side, like university
Yeah.
and like in community colleges.
Yeah. I propose we'll be having a follow-up conversation about that because I think that's something we'd love for the Florida Photonics Cluster to partner with the Institute and the Engine and some other entities, Miracom, those who are so active in the education field to update this and bring in some folks, maybe work with some of the key industry organizations like SPIE and Optica and their education areas as well. Well, we do have some questions, and so we want to take the last 10 minutes or so here to get to some questions. We've got one from Tyler that's
Mhm.
a little bit more on the technical side. Maybe we'll start with that. For PICs, packaged integrated circuits, waveguides, and fiber arrays, how big of a bottleneck is post-dicing facet preparation before packaging and optical coupling?
Yeah, thanks, Tyler. That actually is a general challenge. And the problem is that usually happens pretty much back end, right? So you've done through all the steps and all the processes, and once you're done at the the product is almost there. You're doing this. So this is so the short answer is it is a it's certainly a very sensitive step. Let's put it this way. Yeah. Um, so indeed, the way I would frame it is like really for many big platforms, the object interface at the chip edge is really one of the sort of least scalable, but also most sensitive steps
Mm,
of the entire like manufacturing flow. So I think you hit an interesting point here.
yeah.
Um, um, and I mean, interfaces, of course, we know why they're important, right? Because they like insertion losses and reflections, and they like directly lead to link budget quality and link budget, think bit error rate, right? Energy per bit, and so on. In fact, the whole metric from a link perspective is it's a mouthful, but here it goes. It's basically, let's say a giga or terabits per second for per shoreline millimeter per picojoule per bit, right? So it's more data per unit shoreline. That's where your edge dicing becomes critical or becomes an relevant part, and the packaging connector piece selected and chosen. And there are many developments right now, right? Terramount, pluggable ones, and so on. Global Foundries pushes quite a lot of this as well. Some interesting developments there as well, and others. Um, yeah, so like the shoreline per millimeter, and then obviously picojoule per bit, like relates to, of course, modulation speed, modulation format, and so on and so forth. And then, yeah. Um,
So if you can help solve this problem, you're gonna help with a big breakthrough in the field, it sounds like, right?
Yeah, at least it's to be honest, this by itself would not be entirely solve an entire section, but
Right.
it is unfortunately it's just one of many
Many.
that
Yeah.
needs to
Yeah.
be addressed.
Yeah.
It's an all of the above, right? So
Right. Yeah.
should get it right.
Yeah.
But yeah, I mean, like, if you break it down, this problem, dicing, obviously, damage, cycle roughness, all this micro cracks, roughness, contamination comes to mind. All of these things we need to address
Mhm.
to get a proper edge. Yeah? And for optics, it could be catastrophic for if not done right.
Mm.
So so the short answer is it is like this very very relevant. So if you Tyler, if you have a solution, your company or your ecosystem has a solution to this, maybe we should see how that can be brought more into the context. And if you want
Mhm.
introductions, maybe just some of the for instance, global foundries, I think is the public knowledge. They, yeah, of course, there's public, but even that aspect, what they're doing is they won last year. They got an MOU from the chips like from the Chips Act, CRDO, the Chips R&D office. Actually, they got one even from the incentives program from the
Mm.
39 billion. They received $750 million to build something called APPC, Advanced Packaging and Pilot Center, up in
Mhm.
Malta, New York, next to Fab 8.
Mhm.
And dicing is part of the advanced packaging activities as well on that. Yeah.
Mhm.
So, but on the other hand, let me also just say that maybe this is silicon photonics. Again, we talked about the other materials, indium phosphide, gallium
Mhm.
arsenide, silicon nitride, where this needs to be done as well. Global Foundries is not doing those, as far as I know. For example, maybe they are, but at least not as a big
Mhm.
scheme. Um, and uh, and then there's also glass, glass
Mhm.
panel. For example, something Intel is pushing developing, and is could be the next or one of the next platforms. It's exciting because you can send optical information within the glass substrate itself, not intrinsically. You need to do some processing for it, but there's some options for that. And the again input output to that is also something that needs to be very carefully looked at. And yeah, so optical loss, back reflection problems, fiber array alignment, all of these basically like play into this. But I hope this helps. But if you want to follow up, yeah, just like reach out. Happy to talk more.
Thank you for that. And Alexei Glimov has asked a couple of questions here that may be kind of related, I think. One, is there a roadmap either in development or already completed for deploying photonics in AI-driven data centers? And then sort of tied to that, NVIDIA's invested billions of dollars, as many of us have heard, in Lumentum and Coherent for advancing photonics, specifically for AI. So how can Florida, given all the assets we have, position ourselves to attract some of that large scale funding? Where do we fit on the roadmap there, I guess?
And like I say, love the questions. This is actually spot on. Obviously, as we've everything we said here is it clearly points to okay, so we should be part of like this roadmap, indeed. And so um, the short answer is there are discussions on the way for um, smaller and also larger programs. I need to be just between us here, because Floridians, I need to be a little careful what I'm saying. But suffice to say, there is interest. But let me maybe say where the vectors are on this. Yeah. So if you think, for example, about the a rack, like a very nice unit of a data center is a rack itself. Rack features 72 GPUs right now, including a whole bunch of switches. The switches are becoming co-packaged optics-based switches. The switch itself is, at least in the initial, let's say, NVIDIA products, currently still electronic, but the data I/O from those switch back to the shelves where all the GPUs sit is optics. They call them SpectrumX and QuantumX. Has nothing to do with quantum computing, but it's just like the code names that NVIDIA gave them. And they are optics. They will be coming optics now, in particular in Feynman, in the next node after Rubin. And AMD is also very bullish on this, right? Not just to like throw too much at Nvidia, but so this is very like big topic where we need to go into. Yes, so indeed there are NeoCity has space available to build fabs, to build
Mhm.
infrastructure capacity. We need to think about if also we have another or sufficient supply or suppliers ready, meaning the material supplier, the gas suppliers. Yeah, power is available in Florida. That's the good news. On New City, it's I think 230 megawatt right now, extendable to over 300. That is
Mm.
plenty for these kind of fabs at this point. That's good. And let me just put it this way. So from my perspective, Florida is an ideal candidate to build such advanced packaging, fabs. This could be, let's say, for example, a photonic interposer
Mm.
technology, this photonic slash electronic interposer, and a photonic electronic ORDL, optical redistribution layer, where you zoom and have all the photonic data been zigging, zagging on the substrate. It could also be connecting to the external of the package into fibers, and then from fibers into these switches. Yeah, these switches are there, of course, from data center perspective, from all-to-all perspective, like to create like all-to-all interconnectivity, which is important to basically modern machine learning workflows, MOE, they're called. Basically, this is like you have all these little experts, and all these experts are getting like tasks that helps with the like utilization of your tokens that you have available or your compute frameworks basically on the machine learning side. So photonics can definitely play a very core role to essentially optimize utilization. Yeah, tokens per second. Tokens per second equals dollars. Very much. That's
Mhm.
the new currency these days.
Yeah. Yeah.
And photonics capabilities would be key. And then beyond the chip side and the packaging side, there's also assembly. And we have, in fact,
Mhm.
here in Florida, one of the global players, JBill,
Yeah.
on as like assembly of systems of modules and systems. Yeah, this could be racks, for example, for data center, but also other platforms. And two and a half years ago, they acquired, this is public knowledge, right? The
Mhm.
Intel's optical transceiver
Hmm.
product basically. Yeah. So this is pluggables at a time, and of course now next step is co-packaged optics. So like Alexi, like you I like what you're thinking. Maybe this is something we should maybe discuss also after the call or so. But let's put it this way: there is it would be the right. So Florida is certainly from all these aspects quite ready to build such infrastructure. So, and I think we should together keep making the case for that. Yeah.
And I think one of the things that we've heard throughout this conversation today is that there's so much in Florida that can underpins silicon photonics and this integration of photonics into the semiconductor industry, and we have so much to build on. So it's up to us to quote, get our act together and come to continue to come together collaboratively to really pursue these opportunities and bring all those assets together in a way that can continue to drive this industry. So, Volker, thank you. I've just so enjoyed this conversation. I thank you to all of you who have joined us this morning. Hopefully, this has been very helpful to you and you've uh, been able to learn about some new resources, some new connections to be made. Please check out the Florida Photonics Cluster website. We'll be doing more of these webinars to bring you experts and insight and information that can be helpful to you in understanding where various industries are going and understanding how to plug in, whether you're industry, whether you're academia, whether you're government. Our next webinar, which will be in July, we're still pinning down the date, is actually going to be on the biophotonics area because we have quite a few companies and certainly in Florida and in the cluster that are actively working in that area as well as our universities. So there's a lot happening in that field as well. We will be sending a follow-up email to all of you with the link and to the recording as well as to all the different entities that we mentioned. So, Boker, any last words of wisdom, caution, advice, encouragement?
All I'm saying is the sky is not the limit.
I
Space
love
is.
it. I love it. Yeah. Anywhere light can go, right? So, yeah, which is a long, long way. So, all right. Well, thank you everyone so much. Enjoy the rest of your week. Boker, thank you
Thank you,
again.
Carol.